All right, so we're continuing our journey towards a better understanding of the base 12 version of pi. And in the last series of videos, I showed you how to create this diagram that generates all 360 degrees. And we did that using base 12 geometry and base 12 math and the geometry of the dodecagon, which is a new geometric pattern that I'm introducing to everybody. That is a pattern that only really works in base 12. It lines up the 1 in a way that it doesn't in base 10. So we've gone over all of that. Now what I want to do is increase the number of points on our circle. We're going to do that by growing this diagram. We've created this structure. Now we want to make this circle a whole lot bigger and then just start generating more and more points. So we're going to do that first by attaching this diagram to a measuring system so we can kind of measure our circle in bigger leaps, sort of start to grow it exponentially. So we're going to go back to the very first ring of the dodecagon pattern, the very innermost ring where we have the dimensions of 0.5 root 2 are the sections of length of the perimeter, and then the diameter or the radius actually of that diagram going along the 45 degree line or the 39 degree line in base 12 is 0.96 root 2. So you can see that here. We can draw a circle around that. So that's the unit of diameter that we're going to be working with still. And here it is just one unit, and again it's 0.96 root 2. So what we want to do is measure the length of that in centimeters. When we do that, we see that it's 8.5 centimeters long. That's the diameter, the complete diameter of that circle in metric. So now we're going to multiply 0.96 by 10 in base 12. So we're going to get 9.6 root 2. So that ends up being the third ring of our diagram. So we can see that here, 9.6 root 2, third ring. When we look at the information that we get from this third ring of the diagram, we see that we're dividing the circle into 5 degree sections, and actually we can divide that 5 degrees. That's one section of the diameter. We can divide that into half. We get 2.6 degrees are the sections of degree that we get on this particular ring that we're dividing up our circle. And that's interesting. We can see that 2.6 is 1/10 of 26, which is 30 degrees in base 10. So that's what we're doing. We're dividing that 30 degree section into 12 degrees in base 10 or 10 degrees in base 12. And then, of course, 26 times 10 is 260. So we really see how everything lines up here in base 12 in an interesting way. 2.6, 26, and 260 in a way, just pointing out in base 12 or base 10, it would be half of 5 is 2.5, 30 degrees, and then 360. So you just see again how the geometry of the circle and dividing it up really works well in base 12. Okay, so when we have 8.5 centimeters for our section of 0.96 root 2, we multiply that by 10. We're going to multiply our 8.5 centimeters by 12 to kind of juggle back and forth between metric, which is totally a base 10 measuring system. So 8.5 times 12 is 102 centimeters. So 102 is very close to 100. So when we have 12 sections of diameter, or 12 of those little circles, so we can see that here, 12 circles, we get a length that's just over 1 meter. So I'm going to just shrink that down a little bit and say that's our 1 meter length. So we're going to use that as our yardstick. It's kind of mixing my measuring systems there, but that's going to be our section that we're going to work in. We're going to now continue. We're going to go from 0.96 to 9.6 to 96 root 2 and then 960, and keep multiplying by 10 in base 12. And as we do that, we're going to sort of see what our corresponding meters are. We're going to go from 1 meter, we're going to multiply by 12, so 12 meters and 144 meters, and we're going to go along like that. And then we're just going to keep an eye on the angles and degrees that we're getting, as well as our distance from the center of our circle to the circumference, and any other relevant information that I can think of in terms of what this diagram looks like, or the patterns that are generated as it gets larger and larger. Just sort of see what happens as we keep growing the circle, how many points we're generating on the circumference, because you want to get a lot of points now and just see what the structure looks like as we go larger and larger. So again, we're going to do it in short video chunks. That's going to be it for this video, but that's what's coming. We're going to just keep growing the structure and see what happens. Hope you can join me for those videos. Thanks for watching.